How are you all? I hope you all are doing well. We have started lecture series on CSIR, NET, SET, GATE and other competitive exam too. Within that, I already uploaded plenty of the videos on my channel. If you wanted to see this video, you may refer it into my playlist. Okay, in my today's video, I'm gonna explain to you all one of the question from CSIR NET exam, which asked in previous year question paper. Question it is quite easy. We have to apply the limit. Okay, now let's get started on today's question. First of all, I'm going to explain to you all question and then we'll move for detailed understanding of solutions. In our question, we have given which of the following statement are true. Okay, and we have to figure it out which one of the statement is true over here. So question it is from the section for second, that means paper second. So which means only one correct option is there. So we have to figure it out which one of the correct. It is for the 3 marks. Okay, so all options are quite similar, but their answers, when we apply to that questions limit and x tends to infinity, their answers are given. Okay, so let's get started our today's solution. We'll go through the detailed understanding of solution. We have given in our question two different functions. First function, it says that log of x upon x to the power 1 half log x upon x. Okay, second function is there, and here we have to apply limit as x tends to infinity. Okay, so we have to apply limit as x tends to infinity to our f of x. Okay, so f of x, it is taken from these two functions. Okay, so we have to take f of x when we apply limit x tends to infinity, this one and this one. Okay, and options are given. Can it gives answer 0? Can it gives in answer infinity? Okay, so similarly here for 0 answer infinity or answer does not exist. Okay, so very easy question, just we have to apply the limit, okay, to our function. Now let's check out for the first option. Okay, so first question. Okay, so first part of our f of x, it says that limit x tends to infinity, limit as x tends to infinity. What we have f of x here, limit as x tends to infinity log of x upon x to the power 1 half. Okay, now when we apply limit as x tends to infinity, now check out what the answer it is coming from our question. So which is a log of infinity upon x to infinity to the power 1 half. Okay, that means it gives infinity upon infinity form. Okay, it gives infinity upon infinity form. Now whenever we have form like infinity upon infinity, 0 upon 0, whenever function is not defined for some particular point, so what we do in such a case, we apply L'Hospital rule. Okay, which rule we apply here? L'Hospital, because it is a very much important rule. Okay, by L'Hospital rule. Okay, by L'Hospital rule. Okay, so we have to apply L'Hospital rule over here. So we will overcome with this infinity upon infinity term. Okay, so what we do in L'Hospital rule, we differentiate numerator as well as we differentiate denominator till the term which gives us a finite value. Okay, so or value which is exist. Now apply f dash of x and g dash of x for the numerator and denominator. Okay, so what we will get the differentiation of f dash of x. Okay, that means limit as x tends to infinity d by dx of log of x. Okay, and total divided by d by dx of x to the power 1 half. Okay, so what I have done, because of the infinity upon infinity form, I took here differentiation for numerator and differentiation for denominator by using L'Hospital rule. Okay, now differentiate log x with respect to x, which is a 1 upon x. Okay, so limit, it will remain same, limit x tends to infinity 1 upon x total divided by d by dx x to the power 1 half. Okay, so 1 half x to the power 1 half minus 1. Okay, what is the differentiation for x to the power n x to the power n minus 1? Okay, that I applied over here. So next step, what we will get, so 1 upon x as it is multiplied by, take this x to the power 1 half minus 1, that means x to the power minus 1, take it to the, it goes to the numerator. Okay, so 1 half it comes, so here 1 upon 1 half means denominator of denominator, it comes numerator, so it goes to the numerator, 2 it will be a numerator. So here we have x to the power minus 1 half. Okay, so whenever it goes to the numerator, it goes to x to the power plus 1 half. Okay, because whenever we have denominator negative power, so we take it as to the numerator as a positive power. Okay, and we have limit as x tends to infinity. Okay, now let's go for the next step. So 2 out here, 2 by x multiplied by x to the power 1 half. Okay, this is the term. So we can write this as a 2 divided by x to the power 1 multiplied by x to the power minus 1 half. Okay, as a limit we have limit x tends to infinity over here. Okay, so here also limit x tends to infinity. Okay, because we have to apply this limit after of this. So here we can see x to the power 1 minus x to the power x to the power minus 1 half. Okay, whenever base is the same, we add their power. Okay, so x to the power 1 minus 1 half. So we write this as a limit x tends to infinity. Okay, so 2 upon x to the power 1 minus 1 half. 1 minus 1 half. Okay, now here we can see we can apply directly the x tends to infinity over here. Okay, because our function which gives us a finite value and exist value, so we can apply directly limit x tends to infinity. Now apply limit as x tends to infinity, so 2 upon infinity. Okay, and 2 upon infinity, okay? Something upon infinity. Okay, so whenever we have 0 upon something, we write 0, something upon 0 we write infinity. Okay, that means we can convert it is something upon infinity which is equal to 0. So something upon infinity, we got the answer 0. Okay, so which says that our first function log x upon x to the power 1 half, this one is the first function. When we apply limit x tends to infinity to this function, which gives us the value 0. Okay, so I got the first value which is a 0. Now our next task is here to figure it out the value for log of x upon x. Okay, now apply the limit for log of x upon x. Now see what we will get. Okay, so we have to follow the same procedure as we did it earlier. Okay, so what we have to do, we apply limit as x tends to infinity log of x upon x. Okay, log of x upon x. So limit x tends to infinity log x upon x. Now apply x tends to infinity, so which gives log infinity, which is infinity, upon x is a infinity, so which is again infinity upon infinity form. Okay, we cannot determine this value. Okay, we cannot determine this value, so what we have to do, apply L'Hospital rule in order to get the answer. Okay, so apply L'Hospital to the numerator. So limit x tends to infinity, differentiation of log of x with respect to x1 upon x, and x with respect to x is 1. Okay, so which will get limit x tends to infinity 1 upon x. Okay, and 1 upon infinity which gives 0. Okay, so which is given. Okay, so which is given in our question second, log of x and upon x which gives value 0. Okay, and both of the function, it seems like that both of the function gives us the value 0. Okay, so very easy question is this. Okay, we have to apply the limit as x tends to infinity to our both function, and if it is not exist, then go for applying L'Hospital rule. Okay, now let's check out which is the correct option. For your better understanding, you may refer my solution over here. I solved this example here also. Okay, so you may take it for your reference. Now let's figure it out which one of the option is correct. First option says that first value is 0, second value is infinity, but it is not possible. We got the both values are 0. So first option discarded. Second option says that first value is a 0, so this one is also discarded because the option it is given infinity and we got the answer 0. Third option says that both of the values are 0, so option number C which is correct. But option number D, which is gives first option 0, which is correct, but second does not exist. Okay, so option number D which is discarded. So here in our solution, okay, we can discard the option. We cannot make option correct by using counter example. So try to discard the option by using your solution. Okay, you cannot make the option true by using counter examples. Okay, so I discarded first, second and third option, so surely the leftover option C which is a true. Okay, so I hope you all have understood my today's complete solution. Nothing is difficult here. Okay, even after, if you found anything difficult, let me know in comment section. I'll come up with some other videos. So thank you everyone, thank you for my today's lecture.